And also this particular chapter, because this chapter is nicely given in the textbook, that is Engineering Chemistry by Dr. S.S. Dara. So I'll give you the book PDF of this particular chapter also. Now, the basic concept of which is required to understand corrosion, we have already discussed that every metal has its own standard electrode potential, and based on the position of metal in the electrochemical series, we can find out to what extent corrosion will take place and which metal will undergo corrosion, right? Now this is a simple figures that are showing corrosion. These are the nails which are used for the hardware work, and this is one ship which was made by uh, riveting number of steel plates one over the other, and because it was in such water, stagnant water, it underwent corrosion. Now, why this metal underwent corrosion becomes the very first problem. So, why we are studying corrosion? The very first reason is corrosion of metal will affect the economy, and economy is affected by wastage of energy and the material. 25% of annual produced iron is wasted due to corrosion and loss of material is there. Then corrosion reduces efficiency and lifetime of the equipment. It initiates a disaster. Like if the corrosion starts, then you are very sure either it will lead to like breaking or leaking or bursting of the iron tubes. We have seen a boiler tube, right? The boiler tubes will burst if the corrosion takes place. Due to the failure of machineries may cause health and fire hazard. Okay, it helps to conserve the metallic resource which are precious and limited on the earth. So that is one benefit of corrosion. But overall, for human being, when we are expending lot of energy on extracting pure metal, then it is loss of energy and money both, economy both. Okay, so how do you define corrosion? It is decaying or decomposition or deterioration of material, which is usually metal, or it may be an alloy. So it is a chemical reaction between metallic surface and surrounding environment. It is an oxidation process which causes loss of metal from the metal lattice. Various factors responsible for corrosion are nature of metal itself, environment or the surrounding in which the metal is present, the temperature of the system, the design of equipment, etc. So these are some of the factors which are responsible for corrosion to take place. Now, why corrosion takes place? We have seen the very first day that you are having ore. In this ore, metal is present in combined form: sulfate, chloride, oxides, and many more. So this ore is obtained like yes.
Ma'am, above part is not visible.
I can't remove that part. This part I don't know how it goes. Now can you see?
Now it's visible.
Okay. So this toolbar which appears here now, because of that toolbar, I think you are unable to see the upper part. I will see that the next slides they are all having the text content at the lower part. Okay. So why corrosion occurs is the reason is the ores are like lot of energy is utilized or used to convert the oxide form into the pure metal by smelting, reduction, and so on. And then you get the metal, pure metal. And this pure metal, when it is used in the nature or in the environment, like you have number of equipments on the playground, you have number of iron pipelines running from one city to another city. You have number of pipelines of iron which are used in a flat scheme running either to carry the LPG gas, because LPG will be kept at the lower part basement, or the water pipelines. It is seen that number of places you use iron or metal which tries to go back to its thermodynamically stable form. So because it tries to go back to an oxide form which is thermodynamically stable, uh, this process is corrosion which takes place spontaneously or on its own in the environment or in the nature. Okay, so all metals except noble metals have free energies greater than their compounds. Hence, metals has tendency to convert into their compounds through the process of corrosion. Okay, because their energies are greater. So corrosion is the reverse of extraction process that we know very well. So there are different theories of corrosion, why corrosion takes place. Now, the very first when metals were extracted, and then after some years, it was seen that metals show tarnishing. The surface of metal underwent tarnishing, or the weight of metal got reduced. So then the theory was put forth. That time they said that the scientists said that it is the carbonic acid. See, when the rain is there, rain water is the purest form or the distilled water. So it combines with carbon dioxide, forms carbonic acid. So the very first theory says that only carbonic acid is able to bring about corrosion, and according to acid theory, it is the carbonic acid which will react with metal. But then it was found that a nail which was put into the wall, that nail also undergoes corrosion. And the nail head is shining bright white, but the internal part which goes into the wall, that was found to be red. Like if you put the nail in a wall for say 2 years, the nail remains there. Take out the nail and see the nail head, which is there in the air or outside the wall, is not undergoing corrosion, and the nail part, which is inside the wall, it is undergoing corrosion. So then they thought that no, it's not only the carbonic acid formation or acid theory, but there can be dry corrosion or chemical corrosion. Okay, so dry corrosion, or it is also termed as direct corrosion. It is due to atmospheric gases like O2, CO2, SO2, NO2, and fumes of chemicals. Okay, so now mostly it is the oxide layer which is forming because of the reaction with the atmospheric oxygen. And why the cathode reaction takes place, there will be moisture in air. This moisture or humidity in air helps the formation of hydroxide ions um, at the cathode. If hydroxide is formed at the cathode, iron will, the anodic part will give Fe2 plus, so that the hydroxide can react with it and form ferrous hydroxide, FeOH twice. And once Fe atom is leached out of the lattice, it forms FeOH twice, then the further oxides. You have many oxides, different oxides of iron. Okay. Finally, you get Fe2O3 thrice H2O. So the final product is Fe2O3 thrice H2O. So first product is FeOH twice, and the last product is Fe2O3 thrice H2O. So what we see is it is mostly the oxygen. Now these gases you will find more in the refineries. Okay, so if you go to refinery means where you get some crude oil, crude petroleum oil, and then you go for its fractional distillation. Then you have refineries to refine the oil, mostly your gasoline, that is petrol and diesel. Apart from this, you have number of fractions. Okay, so it is the refineries in which you will get more of this because the oil there will be containing sulfur and nitrogen. That is converted to SO2 and NO2 during the process of distillation and all. Okay, so that will have more of this. So these will definitely corrode or react with metal forming because these ultimately with moisture and all will form acid. So that reacts very rapidly with the metal surface. Then the next theory is galvanic or electrochemical theory of corrosion. So it occurs in aqueous environment and that is a conducting liquid due to formation of a galvanic cell. So according to this theory, there should be an electrolyte present in contact with the metal surface, then only an electrochemical cell will be forming and the electrochemical corrosion will take place. So the acid theory, the dry theory and the wet theory, this is also termed as, the third one is also termed as wet theory and the second one is also termed as direct chemical attack. Okay, so dry or direct chemical attack theory is this one. Okay, then coming to the acid theory. Now in this acid theory, what we see, formation of carbonic acid has taken place, CO2 plus H2O. So it leads to formation of FeHCO3 twice, that is ferrous bicarbonate. So this ferrous bicarbonate is when you have oxygen, carbon dioxide and water leads to formation of this and this ultimately leads to formation of FeOH thrice or first FeOH twice and then FeOH thrice. Okay, so generally the acid theory is not asked because this is not the ultimate one. It has many limitations and that is why this was the just preliminary method. Okay, for rusting of iron. Okay, so rusting of iron is due to continue. Rusting of iron continues due to action of O2, CO2, and moisture. Now, direct chemical attack theory or dry theory of corrosion. Now, according to dry theory of corrosion, metal solid undergoes corrosion to form Mn plus metal cation plus n number of electrons. Now, this oxygen which is present in air, this O2 plus 2 electrons, it leads to formation of O2 minus. Okay, so this O2 minus ion is then capable of reacting with your uh, metals like metal solid plus half O2 giving you Mn plus NO minus finally giving you MO. So this is the overall reaction for these two. This is one oxidation reaction, this is the reduction reaction and this is the overall reaction, uh, redox reaction where metal is undergoing oxidation, oxygen is undergoing reduction and you are getting formation of metal oxide MO. Okay, so this metal oxide once formed, this metal oxide metal will never go back to the metal lattice and therefore we say that corrosion has taken place. So the nature of metal oxide film will definitely decide whether corrosion will continue or it will stop there itself. For example, if you are having aluminium, now you have seen aluminum articles and aluminum use of aluminum for number of application. Okay, aluminum windows, aluminum frames and all. So what we see, this aluminum reacts with oxygen, atmospheric oxygen, forming Al2O3. Now this Al2O3 alumina layer which is formed is a very coherent thin film form. Once a thin film of Al2O3 is formed on the surface of aluminium, that is also white in color. So you see that aluminium does not undergo corrosion. The underneath layers of aluminium will not form alumina with oxygen, or Al2O3 is formed only superficially on the upper surface. So if your product of corrosion is very protective in nature, forms a layer on the metal itself and does not allow the oxygen to react with the underneath layer of metal, then the um, metal oxide film formed is protective in nature and uh, protective, or if it is non-porous, then it is protective in nature. If the metal oxide film is porous, then it can't protect the underneath layers of metal. Okay, so such non-porous protective films are formed for metals like aluminum, nickel, chromium, tin, and indium. Okay, whereas a porous and non-porous should be written first because they are the uh, main culprit for corrosion to take place, right? If it is a porous film, you are very sure that this oxygen can diffuse inside through the pores and go to the oxide metal interface and bring about corrosion to a greater extent. Okay, so a porous non-protective film is formed at lithium, sodium, potassium, magnesium, and hence we find that there is a very huge volume of metal oxide formed for these metals. So they undergo corrosion to a very great extent. Now, how can we say that whether the film formed is porous or non-porous? Because if the film formed on the metal surface is porous, then you say that it is non-protective. Just now I told you, porous means through the pores, oxygen will diffuse inside, or it may be non-porous. If it is non-porous, then it will be protective. So to find out this, there is Pilling Bedworth rule. So what is Pilling Bedworth rule? Pilling Bedworth rule will tell you whether the metal oxide film is porous or non-porous. So from that, then you say that it is protective or non-protective, right? So what is Pilling Bedworth rule? Pilling Bedworth rule says that metal undergoes corrosion forming metal oxide. Now, if the volume of oxide produced by the volume of metal consumed in oxide formation, if this ratio is greater than 1, then it is non-porous. If it is less than 1, it is porous. So this is the Pilling Bedworth ratio. Okay, PB ratio means Pilling Bedworth ratio. So what is Pilling Bedworth ratio? V2 by V1. So the volume of metal oxide formed by the volume of metal used in oxide formation. V1 is the not the total volume of metal. It is the volume of metal used in oxide formation or consumed in oxide formation. So you have volume of metal oxide formed by the volume of metal used in oxide formation, that can be written as that is what relation, density by volume. Okay, density by mass is the volume. So this V is replaced by density by mass. So density of metal oxide formed by the volume of by the mass of uh, metal oxide upon the density of metal upon the mass of metal. So you rearrange these terms, you get this is the density of metal oxide by the mass of metal oxide A naught is the molecular weight of oxide and rho naught is the density of oxide or rho zero. So it is mass by volume is density. Okay, mass by volume is density. So volume will be equal to mass by density. I think first I told you other way around. Okay, so I correct myself here. So volume is equal to mass by density. So the mass by density is here. Mass of the oxide, metal oxide formed by the density, and here it is mass of the metal, molecular weight of the metal by the density of metal. So you write it this way and you get the formula. Now if this V2 by V1, the PB, pilling Bedworth ratio, is greater than 1, then uniform cover of metal surface is formed which is non-porous in nature, and therefore it will be protective in nature. Okay, so the film will be protective. If the PB ratio is less than 1, then the oxide film formed is porous and brittle or maybe brittle. Now, if the oxide film formed, the ratio is very high, then also it becomes or it cracks and is not protective. So it should be close to 1 up to 5. 4 or 5 it will do, but if the ratio is very high like 20-25, then it will crack out or flake out or peel out because of very high volume of metal oxide formed. So in such case it will crack and it will be non-protective. So it should not be less than 1, nor it should be very high than 1. So it should be close to 1, then it is non-porous and protective in nature. Now there is a numerical based on this spilling Bedworth rule. Which of the following coating will be protective and why? So the oxide density is given, atomic weight of metal is given, and metal density is given. So you have to calculate the whether V2 by V1 is greater than 1 or less than 1, and that is how. So this numerical is given in the book also. You can go through that book and you can use the formula which is given here and calculate the V2 by V1. So it's a simple numerical. So there's nothing much in it. Okay. Then coming to pilling Bedworth ratios for a number of metals. For different metals, the pilling Bedworth ratios are given. So you see, it is given up to 3, no, 3.4 or even up to 5. But if you are having much higher ratio, then the volume of metal oxide formed is very thick, and that leads to cracking or peeling of the metal oxide. Okay, so it starts from cerium, aluminium, lead, nickel. These are the value 1 point. So these are all protective in nature because they, whereas you see here potassium, lithium, sodium, they are less than 1. So less than 1 means they will undergo corrosion to a very large extent. Now, what is steel and what is stainless steel? Now steel is Fe plus carbon, and Fe plus carbon plus chromium to some percentage is the stainless steel. Now what happens when you are putting or keeping the steel in air, it will form iron oxide. The iron oxide formed will be porous in nature. Due to porosity, it leads to further corrosion. Now this oxide, if it is having pores, so things gas will diffuse in. But along with pores, if it is having diffusivity or conductivity, then conduction of ions or electrons take place from the corrosive environment to the metal oxide metal interface. This is the metal oxide metal interface. and this is the metal oxide interface. Yes,
Previous slide.
yes, any doubt is there? I am unable to hear. Wait a minute.
Previous slide.
No, I can't tell. Your voice is breaking. I can't get the sentence.
He's asking previous slide, ma'am.
Okay. You are not supposed to mug it up. This is just for your information that these alkali and alkaline earth metals will undergo corrosion, and rest of the metals, they have almost like a protective non-porous film formation, and they mostly they protect their metals. Some exceptions will always be there for any general statement given, right? So you are not supposed to learn this. Rest of the slides are more important than this particular thing. But still, see, these are all the common PPTs prepared for all first year students for all section. So if a PPT is there, you may be getting question. So you can expect a question on this also. Okay. So these are common PPTs, and we can't add or delete a number of things. That's why I'll give you the book PDF. If you read the book PDF, more number of things will be clear. Okay.
Done.
Okay. So what we say, the moment you add chromium to it, okay, the moment you add chromium to it, the oxide film formed here becomes a very coherent, non-porous film formation which stick to the surface of metal, and that is why your stainless steel will not undergo corrosion, or you will not find red colored rust formation at the surface. Now, if you keep common salt that we use in our food in a stainless steel plate for say 3 days, you keep it on your dining table, common salt on a stainless steel plate for 3 days during rainy season, or when the moisture is there more in air. Okay, what you will find after 3 days, the place where you had kept NaCl salt, due to chloride, the stainless steel also undergoes corrosion, and you will find red small spots on it. That is, corrosion begins there by attacking this film, and that starts once the layer is exposed, then corrosion will continue. So what is seen by adding chromium, optimum quantity of carbon is maintained in iron, then you can get a passive film formation on the surface. So this is an active film, this is a passive film. Okay. Okay. Now types of chemical corrosion. Now chemical corrosion may be like your if you are having some refinery, you go to refinery, rich of chloride or chloride ore is there, or the chloride is there, then the chlorine gas is coming out, or you are using some bleaching powder in for sterilizing water. So chlorine is produced from the bleaching powder. In such case, the chlorine gas, when it reacts with silver, if there is a machinery part made up of silver, it will form a AgCl solid, which is more protective in nature. But if you compare the reaction of chlorine gas with tin, if you have a metal or metal part or machinery part made up of tin will react with chlorine gas, forming a volatile compound called as stannous chloride. This stannous chloride um, is a volatile compound, and it vaporizes out. And because of this, fresh surface of tin will be exposed, and the tin will undergo corrosion to a very great extent. Okay, then liquid metal corrosion. Now, what are the liquid metals? There is only one liquid metal, that is mercury. So, if you see other metals which are solid at room temperature, a high temperature liquid or molten metal passes through the metallic pipes. So when high temperature molten metal passes through the metallic pipes, the upper layer of these metallic pipes starts eroding out along with the molten metal, and that leads to corrosion or uh, removing the upper layer of metal means your metal part starts becoming thinner and thinner. So that is one type of corrosion caused due to molten metals. Okay. Then corrosion occurs due to internal penetration, dissolution. Example, nuclear reaction. Sodium metal used as coolant leads to corrosion of cadmium. Now some cadmium part is used and there sodium metal is used for cooling or as a coolant. So this sodium metal corrodes cadmium in nuclear reactors. Okay, so this is all regarding theories of corrosion. Now, one more aspect is there in the theories of corrosion. In the dry theory of corrosion, which I don't find the slide here, that's why I'm telling you. Now, if this oxide film form is only porous, then oxygen will diffuse to this surface and the corrosion or thickness of this oxide film will start forming or will be forming at the oxide metal interface. Whereas if this oxide film form is porous as well as porous means diffusivity is there and at the same time conductivity is there. Now diffusion will help the oxygen reach the metal oxide metal interface, whereas conductivity will help the iron metal to get conducted to the surface of metal oxide, and if this metal conducts to the metal oxide surface or interface, then there will be this metal which comes to the surface will lead to oxide formation. So in such case where diffusivity as well as conductivity is there to the metal oxide or the layer formed on the metal, if it is having diffusivity and conductivity, then corrosion will take place at two interfaces. One is air metal oxide interface as well as the metal oxide metal interface. So that is how corrosion takes place at. Corrosion may take place at two interface also, but generally you will find corrosion taking place either here the metal comes out here to the metal oxide interface and gets oxidized, or oxygen diffuses inside and the corrosion takes place at the metal metal oxide interface. So these are the three cases that can be there. Now, coming to the next, that is electrochemical theory of corrosion. Now, according to the electrochemical theory of corrosion or the wet theory of corrosion, or it may be also termed as galvanic corrosion. Okay, so this wet theory of corrosion, excuse me. Okay, coming back to wet theory of corrosion. The wet theory of corrosion says that there should be presence of electrolyte or water or an aqueous solution on the metal surface, then only corrosion, electrochemical corrosion will take place. Okay, but electrochemical theory of corrosion, because according to the wet theory, the conduction of ions takes place through the um, liquid metal or liquid solution which is present on the metal surface. So, like just like your electrochemical cell, the circuit has to complete. So, somewhere you have an electrolyte, and rest is a wire is connected to the anode and cathode. So, to connect the anode and cathode, it says that some electrolyte has to be there. But it is not necessary that every time presence of electrolyte is necessary. If you are having a say a plumbing, okay, iron pipes are there used for plumbing, and the tap is made up of brass, okay, brass, or it may be copper, okay, or some copper rivet joint, something is there. So any dissimilar metal, when they are connected together, then you can get an electrochemical cell formation, irrespective of whether there is a electrolyte present or electrolyte is not present. Because what we see is the atmospheric moisture or humidity accounts for this particular wet part of it, and the electrochemical cell is set up and corrosion takes place. So when two dissimilar metals are in contact with a common electrolyte or common metal came in contact with electrolyte of different concentration, then a electrochemical cell is set up, and once an electrochemical cell is set up or anodic and cathodic areas are defined, so once the anode cathode areas are defined, you start getting the anodic reaction, oxidation, cathodic reaction, reduction, and corrosion takes place. Second thing is the formation of an galvanic cell, and the third one is concentration cell or differential aeration cell. Now, this particular thing, having two dissimilar metal is nothing but a galvanic cell. So one more point that should be added here is uh, this is galvanic corrosion. Then you have a concentration cell or differential aeration cell formation, and presence of crested trough. So presence of crest and trough means the metal surface will not be always very uniform. If you see, it will have an up and down such kind of surface. So presence of crest and trough leads to corrosion. Then formation of a differential metal cell. This galvanic corrosion is because of formation of a due to formation of differential metal cell and um, concentration cell or differential aeration cell. Okay, so this is if a metal surface is exposed to higher concentration of oxygen and some part of the same metal is exposed to lesser quantity of oxygen, then it leads to formation of a differential aeration cell. And once the differential aeration cell is formed, corrosion will take place. Okay. So, and then the crest and trough definitely leads to formation of anodic and cathodic areas, and corrosion takes place. So what is galvanic corrosion? When two dissimilar metals are in contact with an electrolyte, we see the one which is positive for having lower reduction potential, it will undergo corrosion, oxidation, and the one which is having higher reduction potential will act as cathode. Okay, so what we see, I think we have discussed that in a electrochemical cell, your anode is given a negative sign because metal undergoes dissolution and the electrons are retained by the metal. And because of that, since electrons are retained by the metal, anode is always given a negative sign and cathode is given a positive sign. Okay, so what we see, a simple voltaic cell. In a simple voltaic cell, copper and iron are placed, and what we see is this is the nail part is there in the electrolyte solution because of the potential, and externally it is connected only through a wire. There is nothing to like, no battery is connected. It's a electrochemical cell. So due to the difference in the standard reduction potentials of iron and copper, a cell is set up. Copper starts behaving as a cathode and iron starts behaving as an anode. The area of the nail, which is under water, is um, you will find that corrosion starts taking place at the water line, and dissolution of metal takes place from this particular region. Okay. Similarly, if you are having two metal sheets or two metal rods or two metal bars and they are to be connected, and you put a washer here, uh, and the nut and bolt is put. Now you see the iron plate or iron metal will be having different composition than the nut and bolt. You must be knowing that depending on the workability or the pressure which these parts are um, handling, the composition of iron. Now this is also iron or made up of steel. Okay, you call it as stainless steel, but this steel will be all iron material is termed as steel with specific composition of carbon and chromium. So this will be a harder material because this is keeping the two big plates of iron in position. So definitely this will be of a harder material than the plates, and you will find that if there is difference in the potentials of these two, immediately anodic and cathodic areas will form, and once the anodic and cathodic areas are formed, it will undergo corrosion. Now take example of aluminum alloy plates. Now if these are aluminum alloy plates, if it is not iron, if it is aluminum alloy, still the aluminum alloy plates, if you are putting nut and bolt which is made up of stainless steel, now aluminum position will be uh, lower than iron because of formation of Al2O3. Okay, why the position will be lower than aluminum, whereas in the electrochemical series you will find aluminum it as is at a higher position. We'll discuss this taking the other this thing, the previous electrochemical series and all. Okay, so if you see the electrochemical series and the galvanic series, you will find that the position of aluminum is higher in electrochemical series, but the position of aluminum is lower in the galvanic series. Why? Because of formation of Al2O3, a very protective film on the surface of aluminum. Okay, now when you attach a stainless steel nut and bolt, you will find that the iron undergoes corrosion at a rapid rate because this is This becomes this is protected by Al2O3 and the metal undergoes corrosion. Now, if this plate is not of aluminum and if it is of iron, still the corrosion may take place due to difference in the potentials of this stainless steel composition and this stainless steel composition. Are you getting? So I have explained to you two things here. If the metal sheet is iron and nut and bolt is also of iron, but still the composition of nut and bolt to make it harder, more of chromium and some quantity of manganese and maybe some more quantity of carbon is put. More the quantity of carbon and chromium, more is the workability or more harder the stainless steel will be. The sheets, because they are cast into sheets, will not be containing that composition. And once you find that there is difference in the composition, then you see the metal sheet will undergo corrosion in that case. Now, if you consider the example shown here, that is aluminum alloy plates. Now, the aluminum alloy plates, you will find that this aluminum alloy will form Al2O3 layer on it, and because of the Al2O3 layer on it, this part gets protected and starts behaving like an cathode, and this nut and bolt now will undergo corrosion. Okay, so things are clear. So when two dissimilar metals come in contact with each other in presence of common electrolyte, the driving force is greater than the potential difference between the metals is found to be more. So driving force to for carrying out the corrosion. Now here different type of parts are shown. Copper plumbing connected to steel pipe, lead and antimony around copper wire. This type of diagrams are shown here. This is, I think, the copper part. This is the steel part, and this white part is, I think, some alloy, and this is the copper part, or this is the steel part, and this is the copper part. So this is how, like in day-to-day life, you can see the corrosion taking place due to formation of differential metal cell. So this is an example of differential metal cell. In a single example, I have told you two different stainless steel sheets. One is sheet and one is nut and bolt. Still corrosion will take place. If you are having aluminum sheets and the nut and bolt is of stainless steel, still corrosion is going to take place. So when two dissimilar metal come in contact, one of them will be lower in the galvanic series, so will act as a passive metal or cathode, and the one which is upper or placed higher in position at the top will undergo oxidation and act as anode. Okay, so this the what is written here? Galvanized steel. So steel coated with zinc, zinc is sacrificed to protect steel. So when zinc is coated on steel, zinc will sacrifice itself or will undergo oxidation, and iron will never come out for oxidation. A tin can or a food container, steel coated with tin, tin is sacrificed to protect the steel. So these are some of the examples of sacrificial protection. Okay, then coming to next, that is a local cathode, like on a metal piece. Okay, if you are having a metal scale and take a container in your house and drop a metal stainless steel scale, okay, 15 centimeter stainless steel scale, put it in a vessel and put water into it, and then you try to see after 15 days what you will find on the metal strip. There will be formation of some local cathode and local anode. Now, generally, this local cathode and local anode will be formed if you are having, like, if a drop of cement or drop of something has formed fallen here, then it leads to formation of anodic area. Now, if there is no impurity present in the water, water is very clear and good in quality, then this metal is there. Now the metal composition is same, but there will be some part of the metal where more of stresses are there. Now to understand what is meant by stresses, internal stress means when molten metal is cast and a sheet is made. When you make a sheet, you will find that solidification takes place at a and grain centers and grain boundaries are formed. Now, some region which experiences or has a greater stress that or strain, it will undergo oxidation because that starts behaving like an anode. So the stressed part will behave as an anode, and the unstressed part, compared to this stressed part, will start behaving as a cathode. The moment they develop anodic and cathodic areas, corrosion starts. So, what is the corrosion reaction? From the anodic area, which is more at stress, Fe will go into this electrolyte as Fe2 plus, and the two electrons will run from this place to this place. Now, whether you say two electrons from one Fe atom or four electrons from two Fe atom, it is same thing. So, if you consider two Fe atoms going as Fe2 plus, then four electrons will run from this anodic area, local surface, and it will migrate through this metal itself and will come to the cathode region. Now, at the cathode region, these electrons will be mopped up or used up. So these electrons, four electrons with H2O, leads to formation of 4OH minus. This 4 negative charge with twice H2O forms 4OH minus. Now once 4OH minus has formed, this 4OH minus and the 4OH minus formed, that is due to the reaction of O2 and H2O. This 4OH minus will react with or combine with this twice Fe2 plus, leading to formation of FeOH twice, the first product. Now this FeOH twice will further form FeOOH. Okay, so this is how, and then finally, like it will go on converting into the second rust product, then the third product. Finally, Fe2O3 thrice H2O is formed, and that you call as rust. Things are clear? So that is how further ahead, more and more of half O2, half O2, half O2 will come, and finally Fe2O3 will be formed. So this is the general electrochemical reaction occurring at the anode and the cathode surface. Then, the question is, give an outline of an electrochemical theory of corrosion and explain the mechanism of rust formation in anodic and alkaline media. So today we will stop here, and the anodic and the acidic and the alkaline medium, how metal will react. So metal, mostly it is the iron which is used extensively in all industries, all machineries. So corrosion is also extensively studied for iron. Okay, and that is why we talk about iron first and then other metals. So today we will stop here. I'll give you the PDF of this particular chapter, in which electrochemistry part is also there and the corrosion part is also there. Okay, and most probably today I'll give you some assignment from your portion, that which will be for 10 marks. Things are clear? Everyone is getting? Now in the assignment I'll put the deadline also. So you have to submit your assignment by that deadline, because today is 14th and we should wind up all our courses, the practical evaluation and your theory evaluation should be ready by first week of March. Okay. So should we stop here? Any doubt till now? No one is listening to me.
Ma'am,
Yes,
You will post the lab practical PDF also on the group, please.
the ion exchange capacity, right?
Yes, ma'am. Yeah.
Yes, ma'am.
Yeah, yeah, I'll put that also.
Okay,
Okay.
ma'am.